Hello, hello. Awesome to have you here, guys. Greetings from Bulgaria and welcome to our third office hour session. I am super happy to see you guys tuning in. Say hi in the comments. Don't be shy. I'd love to know where you're joining from. While we wait for the others to join in, I'd like to make a quick intro. My name is Lora, and I am what you call a web performance enthusiast. Apart from being one of the faces in our workshops here, I spend the rest of the time developing content around everything site speed and core web vitals. With me today is Atanas, a technical expert here at NitroPack. He knows the ins and outs of speed and performance issues, and the best part is he knows what to do when they occur. Today's session is dedicated to reducing page load time, and we have divided it into two parts. We'll start off with a brief rundown on page load time, what it is exactly, what important metrics you need to focus on, and common causes for slow page load time. Then I'll let Atanas take over to show you the techniques with most impact on page load time in action. Of course, the session is being recorded and will be uploaded on our YouTube channel later. If you have any questions, drop them in the comments. We'll keep an eye on them at all times. So, what is page load time? Simply put, it's the time it takes for a web page to load and display all of its contents in the user's browser. An important note here is that page load time only measures the time it took to initially load a site. It doesn't measure requests that happen after the initial load. In other words, once the page has loaded and people start interacting with it, no additional measurements are attributed to the initial load time. So, what is a good page load speed, you might be wondering? Translating that into seconds, under 2.5 seconds is good. 2.5 seconds to 4 seconds is something that needs improvement. And over 4 seconds is now considered bad. So, according to Google, your website's content should have a near imperceptible load time. They are, in fact, aiming for half a second load time. For reference, a 2023 study shows that the top 100 websites in the world have an average load time of 2.5 seconds on desktop. However, on a global scale, the average is a whopping 10.4 seconds on desktop. So that's a huge difference. And we don't want to be on the slow side, right? So a common misconception out there is that page load time and server response time are the same. In truth, it's a similar concept. While page load time measures how long it takes to display an entire web page, server response time describes the time until a response is received. These terms are sometimes used interchangeably, and while response time does influence page load time, they are not the same. To better understand that and what happens in a page load exactly, let's look at a performance report. This is a film strip I took from GTmetrix right before we went live. With this visualization, it's super easy to see that the server response time is in fact part of the whole page loading process. I've marked that in green on the screen. The strip I've marked is what I like to call the blank time in performance reports. It's super important as it affects the whole page load experience, and the slower it is, the more site visitors have to wait to interact with your website. So, a chain of events happens when a user accesses a website, marked by the time to first byte, or also known as TTFB. This blank time includes backend data on network connection speed and server response times. For reference, time to first byte is the time from the start of the navigation to the first byte of data returned to the client. Here is a simplified view of what happens when someone opens your website. First, a DNS lookup occurs. Then this establishes a connection to a DNS server, which matches a domain name to its corresponding IP address. Then an HTTP request is made to that IP address, and then the server sends across data. And this is when TTFB is measured. Afterward, the browser parses the HTML and renders the web page to the user. This initial HTML may initiate further resource requests such as style sheets, JavaScript files, images, etc. Once all synchronous resources have been loaded and rendered into the browser's window, a page load event is fired, marking the completion on the web page load for your visitors. So, now, you may think that focusing on TTFB only may be enough to reduce your page load time, but while optimizing TTFB should definitely be part of your strategy, it shouldn't be the only metric on your list. Optimizations rarely impact only one metric, and I wanted to demonstrate what happens when we deactivate the NitroPack optimizations on our website and run the GT metrics audit again. As you can see, there's an immediate difference in TTFB. We went from 725 milliseconds to 1.3 seconds, and page load time went from 1.2 seconds to 2.7 seconds. So that's a huge decrease in page load time. This means our efforts not only affect TTFB, but other metrics like first contentful paint, largest contentful paint, time to interactive, and on-load time. Which brings me to my next question. What affects page load time exactly? Well, their most popular culprits are lack of caching techniques, render blocking resources like sliders and carousels, unoptimized images and large media files, inline JavaScript and CSS files, not implementing Gzip compression, and of course, too many HTTP requests. And as promised, I'll let Atanas take over and share his favorite tips for dealing with these and ultimately reducing page load times. Atanas, it's your turn.
Hello everyone. So a few tips from me to further improve the page load times. One thing that many people try to avoid and don't pay attention to is choosing a reliable hosting provider. This is crucial for the lifetime of your website because it really depends. Everything starts with the hosting provider, and it really depends on the type of the website you're running. For example, I'll give you an example why the hosting provider can affect your page load times. Let's say you have an online shop in the United Kingdom and your customers are in the United Kingdom, but for some reason you have chosen to use a website in the United States. So what happens is that when visitors from the United Kingdom visit the website, the data has to travel to the United States and then go back to the United Kingdom to deliver the data, and then the whole rendering process in the browser starts. This is obviously a no-go, and a better approach would be to choose a server that makes more sense. In that case, it would be a server in the United Kingdom because it will be less physical distance for the data to travel in between, and this impacts the I'm sorry, just a second. It impacts directly the time to first byte. And moving on to the demo I have prepared today, I have the same website like in the previous video, and we're going to take a look at 3 pages and 4 different techniques to improve the page load time. Another one is to use caching and code minification. Using caching solutions for your website ensure that the server doesn't have to run all these complex calculations every time somebody requests a page, but they're going to have a cached version of a web page, and they're just going to give the cache version, which cuts significantly the time to first byte, but more on that a little later on the stream. And code minification, that's where the code is, the blank spaces from the code are removed, and the code is just simply made smaller so it can travel quicker on the network. Another tip is to replace sliders with static images in above the fold. The reason for that is that sliders typically require JavaScript to render the page, and this refers to reducing the render blocking resources. When you have a slider and you want to display it it's inevitable that the browser has to download the JavaScript and render it. But this takes from the CPU time in the browser, and this just significantly slows down the whole page load time. The next thing is compressing and lazy loading images. This is a well-known technique, but I want to show you why relying on plugins or caching solutions to compress your images may not be enough, whereas almost all of them provide lazy loading. The compression of the images is really important when uploading to WordPress. The last thing is to apply a Gzip compression. Some of you may have heard of it, and I'm going to demonstrate what are the savings that you can benefit from while using Gzip compression versus not using it. Moving on to the website, we have 3 pages. One is a home page without cache. As I have refreshed it, you can see that it takes a while to spin and just load the page. The next one is an optimized page. It's cached using NitroPack. All of the techniques are used here. The images are compressed. There is lazy loading for images. Resources are optimized. And I'm going to refresh it. As you can see, it's almost instant. Moving on to the slider page, it's the same page as this one, except for the slider that is added on the top instead of the hero image. And it still loads fairly quick, to be honest. But we'll move on to the GT metrics reports, and specifically to the film strip, as we call it, to see what exactly happens on each one of them and why using caching and other mechanisms is helpful. This is a test I ran just before the video, so I don't waste your time. And we're looking at the time to first byte here, which is a very large number. It's 2.4 seconds. And by the way, the server I'm using for this demo website is located very close to me. So although it's located close to me, the time to first byte is still slow. You might be wondering, why is that? There is 2 parts of the time to first byte, actually. Well, there is 3, but in my case, I don't have redirects. The first part is connecting, as my colleague Lora explained, and the second one is backend, as GTmetrix calls it. The backend part of the time to first byte is the time it takes for the server to output the content. I already mentioned that earlier. So the less powerful the server is, the more time it's going to take to render the content. It's going to influence this backend time here, which is going to drag everything after it going forward. GTmetrix says that the fully loaded time for the non-cached version is 8.9 seconds, which is a lot of time. But actually, the page becomes usable at around 5.8 seconds or something. When we have the time to interact it's usually when the page becomes usable. And on-load time is at a similar timestamp. I'm going to show another report for the page that is cached using NitroPack. We have lazy loading enabled. We have combining of CSS enabled. And it's the same server, it's the same page, the same layout. And I want to show you the difference. In that case, I'm sorry, this is the slider part. I'm going to move to it after this one. This is the home page, just without the no cache, just like the no cache page. It's the same. It has NitroPack. It has all the optimizations. And the first thing we're seeing here is that the time to first byte has been reduced to almost 400 milliseconds, and the backend time from 2 seconds is now 200 milliseconds, which is 1/10 of the other time to first byte backend section. So what this means is, just by having a caching on the website, we're reducing the time in the server it takes to process the request 10 times. Of course, the page will not load 10 times faster, but improving the time to first byte is crucial for the next events that occur in the loading process. Comparing the two pages one more time, we can see that we have content here and time to interactive just near the 0.7 second, whereas here we have it on the 5th second. So somebody visiting this page is going to wait 5 seconds to see the page and start working on it and start doing whatever. And here we're going to have somebody just click on the page and in less than a second it's loaded. And they can start interacting the page, they can scroll it. The fully loaded time in that case, it also refers to elements that load asynchronously, but we have the main content here. So this should not be the holy grail of our optimization. Sometimes it may not be the most useful metric. What we are aiming for is having a website that looks okay, that is not broken, and it can be interacted with in a very short period of time. I will move now to comparing the home page with a still image. This refers to replacing sliders with static images, and the home page with the slider. As we can see, the score is still A grade and the performance is 90%, but I want to move your attention to something else. Here on the slider version, we have the page slightly slower, becoming interactive, and it's around 1.5 seconds, or somewhere in between 1.3 and 1.6 seconds. So in some cases, this can be ignored visually because, as you can see, it's loaded fast. But when you consider having multiple heavy elements on a page, and if the slider is not the only thing that's loaded above the fold, having JavaScript heavy parts above the fold can drag this down up to the second, and then this becomes a very not really interactive website. Visitors have to wait when they open it, and they don't want to do that. They will just bounce and visit another website. The time to first byte is similar in that case because the cache is still a cache, but this period between here and around here is the time that it takes for the browser to receive the initial HTML, to download the JavaScript, so the JavaScript can run inside the browser and can render the slider. Of course, there are cases where you want to show a slider, and that's not a huge issue, but I suggest everybody to try it for themselves and see what works best for them. Overall, if you keep a track of your Google Core Web Vitals over a month of time, if you make an A/B test and test a month with a static image and a month with a slider, you are going to receive enough data to compare the difference. Moving on to the next part about images. In our previous workshop, I showed you why having lazy loading for images is a good thing, and this still remains the effect. Lazy loading images is almost required nowadays because when people open the website, they only see the first visible part. They only see this image, so they don't need to download these three images. These three images can be downloaded as soon as the user starts scrolling. And when you upload large images to WordPress, there are certain plugins that do some sorts of compression, optimization, make them smaller. And this is at the cost of using the computing power of the server. And I'm going to want to show you another way you can compress images before uploading them to WordPress, which is going to save a few megabytes on the hard disk and will guarantee you faster load times if those images are above the fold. The tool is TinyPNG. Some of you may have heard of it, some of you may have used it. I'm going to just do a quick demo here. I have a few images downloaded from Unsplash. It's a website where you can download free images, but don't forget to attribute the authors. And I'm going to load an image that's 2.5 megabytes. And immediately it's compressed down to 500 kilobytes. So just by running the image through this website, we have reduced its size 5 times or 78%. And now when you upload this image to your WordPress, you can still have a caching plugin like NitroPack or image optimizations plugin that will further compress the image without losing the quality. And talking about quality, I want to load this image that I just downloaded, that I just compressed and load it inside the browser. And I'm going to load the original image as well. Oh, sorry, that's not this one. Which one was it? The laptop. Okay. So these two are the same images, but the left one is just compressed. There is no difference that the eye can see. And when you upload them to the site, to your website, the further compression and optimization methods can lower the size even more, which will help you with achieving a quicker page load time. Of course, that's combined with the lazy loading and all other techniques like having a good server, using caching, optimizing resources, minifying and combining them where possible will help with improving the page load time. And the last thing I want to talk about is using Gzip or broadly compression. This type of compression reduces the size of the HTML that is shipped to the browser. So if you have a 200 kilobyte file and you have a 50 kilobyte file, you can ship the letter faster because 50 kilobytes is smaller than 200. NitroPack has a feature where we can automatically detect that if the server has Gzip enabled, and we can enable that automatically for you, or you can have it already enabled on the server and we will not touch it. But it's a good thing to check and confirm that your website is using Gzip, because this can have also an impact on the page load time. And for this, I'm going to show you another report from GTmetrix, which compares the same optimized page, but this one here doesn't have compression enabled, and this is what GTmetrix is suggesting. It's saying that we have a potential savings of 173 kilobytes. And looking at the score, it's a green one, it's in the 90s. A naked eye may not make a difference, but I want to pay attention to the first frame where the page becomes responsive and people can interact with it again. On the maximum cached and optimized version, it's around here in between 0.5 and 0.8. But here, this first frame has moved a little bit. It's it's at the around the first second. So in the case where you don't have Gzip compression, there is still a slowdown introduced, which can be easily resolved by simply enabling Gzip compression. Using all of these techniques and caching specifically, but all of the little things that work along with caching, like code minification, image lazy loading, resource optimization, Gzip compression, can help you significantly improve the page load time. And as I'm always suggesting, don't pay attention to the final page load time, because users typically interact with the page before it has finished loading all of the things in the background. Anura?
Okay, thanks, Atanas. Gzip is a neat tip here. I really love using Gzip compression. It's super helpful to see all the optimizations in action. Let us know which one you'll try next and drop any questions for us in the comments. We'll try and answer them all right away. Before we wrap this up, I also wanted to address one final tip we had included in the list earlier, and that's reducing HTTP requests. In April, we had a dedicated session on HTTP requests, which you can find on our YouTube channel at NitroPack. So definitely consider this, consider adding this to the queue. Thank you all for joining us today. It's been awesome to have you again. Stay tuned for the next office hour session in June. We'll be coming right back with a date. And I want to wish you an awesome day or evening, wherever you are, and see you soon. Bye.